Okay, so we're recording now. All right, so the rocket starts with an initial velocity of 50 meters per second. They tell us that it accelerates at 2 meters per second squared upward. Upward is what? Positive. Okay, and then until the engine stops at an altitude of 150 meters. So we got USA. So what's the significance of the engine stopping? Right here, the engine dies. What's the significance of the engine dying?
The acceleration goes to -9.1.
The acceleration changes. So I'm going to draw a line right here. The point where the engine dies indicates where we have a new acceleration. So the acceleration up here is going to be gravity, which is -9.8 meter per second squared. All right, so I'm going to label this A1, A2. We're given X1. They tell us the height of the rocket when the engine dies is 150 meters. So that's X1. Now, when the engine dies, is the rocket just going to go and stop, like right there, like on a dime? What's going to happen? The rocket's going to keep going higher, 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 until finally, just like throwing a baseball up in the air. What do we know about this max height up here? So right here is the maximum height. There's something we know about this point, even though it doesn't say it in the problem. Rafi.
Velocity is 0.
Nice. Do you remember that from me teaching you that?
No, I took physics in college.
You did? But hey, but I taught it to you first. I taught it to you first. So see? Hey, was physics in college hard?
Yeah.
Harder than my class?
Yeah.
Oh, it was? But was my class still awesome?
Yeah.
Great. Okay, good.
No,
Okay.
I kicked everybody's butt because of you.
Oh, thanks, man. Okay, so V up here is 0. Stops for a split second. And then let's label the height here. So that we're going to call this X2. So we got X1, X2. V final up there is 0. How about times? So we're going to call time, for this first part, T1. Do we know the time for the first part? Nope. That's a question mark. Do we know the time for the second part? Nope. That's a question mark. Now, what other piece of info, very similar to a problem we already did today, what other thing is going to be important in this problem? And it has to do with this point right here, the point where the engine dies. When the engine dies,
Final velocity or initial velocity for the next part.
Yep, the final velocity for the first part. Rafi, you're killing this problem. You remember how to do it. You're good at physics. I take credit for that. Okay, the velocity at this point, this velocity right here, it's the final velocity for the first part, but it's also the initial velocity for the second part. Okay? So we got the problem set up. All right, first question. What is the maximum height reached by the rocket? Maximum height reached. Well, we already have X1. We already know that that's 150. So to find the maximum height, what do we need to find? X2. Are we ready to solve for X2? We are not. We don't have enough info. There's something we got to solve for first. Before we can find X2, what do we have to find? Find V final for part 1. Okay? And by the way, V final for part 1 is V initial for part 2. And then once we know that, then we can solve for X2. Okay? So how do we find V final for part 1? So now you got to have your motion equations. And you guys know you have to have the equations memorized for the quiz. Memorize the equations. So which motion equation could we use to find this V final?
The second power.
Uh-huh.
Initial velocity of the second power plus 2 AX.
Yep. Okay, so this is going to be VF. V initial is 50, so this is going to be equal to the square root of, so V initial is 50 meter per second squared plus 2. Now don't forget to make acceleration negative. Negative 9.8. And then this is going to be 150. Does anybody have this so I don't have to calculate it? What does V final come out as? Use what? Oh, man. Hey, bad Spaldo. Hey, pretend I didn't do that. Okay, start over. Hey, thank you very much. Right here. I was trying to show off here for my former student, Rafi. I was getting all cocky. Hey, man, what's our acceleration? 2. Sorry, Rafi.
No problem.
I let you down. Okay, that's better. Thank you. The acceleration's not negative 9.8. It's 2. Okay, V final. Who's got it? All right, that's nobody. Let me do it. Oh, you got it? 55.7? 55. Is it exactly 0.7?
No, I just rounded it.
55.68. That it? Hey, if this is wrong, I apologize. Okay. It's somewhere in there. Hey, don't use, because the thing that's going to happen here is we're going to use this velocity in another calculation. Don't round till the very end. Okay? Don't round till the very end. So now that we have this velocity right here, positive 55.68, now that we have that, we can solve for x2. So what equation can we use to find x2? To find x2, we could go, oh, I know, I like this. We'll use the same equation. We'll go VF squared equals V initial squared plus 2AX. What is V final for part 2? 0. At the very, very tippy top, V final is 0. So I'm going to shrink this. I'm out of room. Okay, so solving for x. So x2 is going to be negative V initial squared over 2a. So that's going to be negative 55.68. Oh man, look. You really don't want to use rounded numbers here. Why? Because what are we doing here? We're squaring it. So if you'll get rounding error there. Don't round till the end. All right, 2 times negative 9.8. So then this gives us 55.68 squared divided by 2. This gives us 158.2. Positive. Hey, notice the negatives cancel. Does that make sense? Should the negatives cancel? Yeah, because x2 should be what? Plus or minus? Plus. x2 should be plus because why? It's going, the rocket is moving up, and up is plus. Okay, so what is the total height going to be? The total height is going to be x1 plus x2, so you add these together and you get 308.2. So this is just a multi-step problem where you have to combine part 1 with part 2. Okay, second question. How long after liftoff does the rocket reach its maximum height? So I'm going to erase all this because I need more room. Everybody got that? So now we're solving for how long after liftoff. So we have to solve for T1 and T2. So it's just multi-step. Okay? So how do we get T1? I would go VF equals V initial plus AT. So T is going to be V final minus V initial over A. So V final is 55.68. V initial was 50, right? This is V final, that's V initial, and the acceleration was 2. So this is going to give us a time of 5.68 divided by 2, 2.84. So that's T1. T1 is 2.84 seconds. Okay, now we solve for T2. So to solve for T2, So T2, I would go same equation. I'm just going to use this exact same equation right here. So T is going to be 0, right? V final for part 2 is 0 minus V initial, which is 55.68. What's the acceleration for part 2? Negative 9.8. So what happens to these negatives? They cancel. 55.68 divided by 9.8. So we got 5.68 seconds. So T2 is 5.68. So the total time, you're going to add T1 and T2. And you get 8.5. Now you can round it. 8.5, that's fine. 8.5 seconds to the top. Now, last question. How long is the rocket in the air? Well, do we just double the 8.5? Can we just double the 8.5? No. Why not? Rafi, do you know why? Yeah, look, on the way up, how many accelerations were there? 2. On the way back down, what's the acceleration the whole way? Negative 9.8, right? It's different than the way up. The way up had 2 accelerations. The way down has 1 acceleration. Physics is thinking class. Oh, Rafi, that's new since I had you. I never said that when I had you. I sold my rowing machine to a dude. Anyway, you got to solve for the time down. I'll do it here real quick just so the video is complete. So I would go, here's how you do it. 1/2 AT squared. Hey, what's V initial when the rocket starts at the top? 0, so the time down is going to be 2x over A. Oh yeah, guys, hey, I ran out of time. I'll check your homework later. What do you mean? Yeah, homework was due today. So this comes out as hey man, hold on, I'm finishing it. I'm actually recording it, so 7.9. So the total, how long in the air, so it's going to be that plus 8.2, 16.1.
That's nice.